Assalamualaikum. My name is Akil Hazim and I'm here with my group mates Adib, Farid, Arfan, Sufi and Arif from Group 6. We will present to you our project about GrabFood. So we will start with report 1 and I'll be explaining about the entity relationship diagram ERD. So we will start with report 1 and I'll be explaining about the entity relationship diagram ERD. First, let's look at the entities. First, we have customer. Each customer has an ID, email, name, and location. The customer ID is the primary key, which uniquely identifies each customer. Second, we have order. An order has an order number, date, quantity, and total amount. The order number is the primary key for this table. Third, we have the menu. The menu stores items with a menu ID, name, and price. Menu ID is the primary key. And last one is the restaurant. This includes restaurant ID, location, and name. Restaurant ID is the primary key for this table. Now let's move on to the relationships. First relationship, we have the customer to order. The relationship is many to many, meaning one customer can make many orders and one order can be linked to multiple customers. Second, we have order to menu relationship. This is also a many to many relationship. One order can contain multiple menu items and one menu item can appear in many orders. Lastly is the restaurant to menu relationship. This is a one-to-many relationship. One restaurant can prepare multiple menu items, but each menu item comes from only one restaurant.
I will be presenting for report 2, which is the normalization step from UNF to 2NF for GrabFood system. In UNF, all the data is stored in a single table with repeating groups, which means that a series of attributes that are being repeated throughout the database. As you can see on the table right there, all the data is stored just in one table, and there are also repeated attributes throughout all the database. So from UNF to 1NF, we remove repeating groups and we separate each order into its own row. As you can see on the table, each cell holds only one value. So and from 1NF to 2NF, we remove partial dependency and create separate tables for related entity. We split into 3 tables, which is order detail, order, and menu, with each their own entities.
Now, I will explain the step from 2NF to 3NF. In 2NF, we already made sure that the data does not have partial dependency. But in 3NF, we want to remove transitive dependency. This means we don't want one non-key column depending on another non-key column. To fit this, we separate the data into smaller table, which is order detail, order, menu, customer, and the last one is restaurant. So order detail only has order number, menu ID, and order total. So the orders table show order number, order date, quantity, and customer ID. So the menu table store menu ID, menu name, price, and restaurant ID. And customer table store customer ID, email, name, and location. And the last one is restaurant. Restaurant table keeps restaurant ID, location, and name. This way, each table only include data that depends on the main key of that table. We avoid repeating info, reduce error, and make our data cleaner and easy to update.
So now I will explain report 3, so which is data definition language. So for the first one is create database and connect. In this step, we create a new database called GrabFood using the command create database GrabFood. After that, we use the command use GrabFood. This means we are now working inside the GrabFood database. So next, now we create 2 tables, which are restaurant and customer. So for the restaurant table store, the restaurant ID is unique ID for each restaurant, which is the primary key, and the rest location is the address, and rest name, the name of the restaurant. Next is customer table stores. Customer ID is unique ID for each customer, which is the primary key. Customer email address, customer name, the name, the customer name, and the customer location is the address. Each table has a primary key to make sure each row is unique. So next. The next part is foreign key. So next we create 3 more tables, which are menu, order, and order detail. So for the menu table includes menu ID, menu name, and restaurant ID. So for the restaurant ID, link to the restaurant table using a foreign key. And for order table includes order number, order date, order quantity, and customer ID. And last, order detail table stores the detail for each order. So it includes order number, menu ID, order total. It uses a composite primary key and also has a foreign keys linking to order and menu. So next. So is the for number 4 is insert data into table. So now we add sample data into all 5 tables. We insert data into restaurant, customer, menu, order, and order detail. This data helps us simulate a food ordering system with restaurants and customers, menu, and orders. Next. So number 5 is view table. Now we select to view the data view that we just insert. So customer table shows 4 customers with email and addresses, and restaurant tables show 4 restaurants including McDonald's, KFC, Starbucks, and Crony. And next. So for number 6, is drop table and show table. Here we delete the table order detail using SQL. We use the command drop table order detail, and then we use show tables. This command displays all the remaining tables inside the GrabFood database. And select from menu and order table, we run select and from menu to see the menu items and all order records including order dates, quantities, and customers IDs. Lastly, we use the command select stuff from order detail. This shows us all the order details like the order number, the menu ID ordered, and the total price.
Today I will present a series of SQL queries executed on a GrabFood database demonstrating various data retrieval and manipulation operations. Okay, first, it shows that select menu name, menu price from menu where menu price. The result is fried chicken, mocha frappe, nasi goreng ayam, burger cheese. Mocha frappe is the most expensive item, and most high value items are main dishes and beverage. The purpose is identify high value menu items. Okay, next. For number 2, the purpose is to check available menu items from a specific restaurant. For the SQL is select menu name, restaurant ID from menu, and where restaurant ID. NA4. Result is extra sauce, nasi goreng ayam. For the insight is restaurant NA4 offers energy drinks, that is extra sauce and fried chicken, and fried rice, nasi goreng ayam. This is useful for restaurant specific promotions. Next. For the third one, the purpose is to identify bulk orders. Select order number or order quantity from order where order quantity more than one. The result is 01002, 01005. Only 2 orders had multiple items and possible group orders or combo deals. Next. For this one, for number 4 is to analyze order trends in April 2025. The SQL is select order number, order date from order where order date between 2024 041 and 2025 0430. The result 0101, 01, 004, and 01005. It shows that 3 orders were placed in April and peak ordering around late April. Next. For number 5 is to identify high value transactions. Select order name, order number, menu name, order total from order detail where order total more than 10. It shows order number, menu ID, and total ringgit. BO3 mocha frappe appears twice, suggesting popularity, and average high value order is 15 5 cents.
Alright, today I will explain for SQL from 2 tables. First is find menu for restaurant Crony. So this query display all the menu items offered by a restaurant named Crony, which is extra sauce and nasi goreng. Next. Then for this image from the query show all orders placed by the customers named Aiman. Next. And then we display all menu items that cost more than 10,000, which is the data gets fried chicken, mocha frappe, 2 mocha frappe, and nasi goreng ayam. Next. Okay, reset. Okay, for the 4, we identify customer who placed order before 23 April 2025, which is we get Aiman, May, and Adam. The data show customer name, customer email, and the date. Next. And lastly, we find order detail for menu mocha frappe. So it show which order include the menu item for Alright, that's all.